Oh, okay. Good afternoon. So let us start today's lesson. So that is actually from now, whatever we study here, you need to be alert that it might be in the exam. So that is chapter 2. The repetition is done. If you remember, we did a very boring thing last time. No, the previous time. So now we want to start algebra. Algebra is actually a very, very important topic. So in principle, we have algebra and geometry, the main two branches of mathematics. So now here we want to start the very first principles of algebra. What we want to, let me just give you a little bit of idea why this is important. So here what is important for us is the set of real numbers, okay? So we have the set of real numbers, and every number that you know about, except if you also know about the complex numbers, forget about them for the time being, just consider about the real numbers. Any number that you can write, 1, 2, 3, minus 7, square root of 5, I don't know, pi, e, any number that you can imagine is a real number. So that's a very, very important set in mathematics, and we have two main operations defined on this set. The two main operations are addition and multiplication. So addition, we use this symbol. Multiplication, probably we use the dot. Okay. Of course, here in algebra, the point is that not to start with specific numbers. Here, if I give you 2 plus 3, of course, you immediately add them and you give me the answer equals to 5. If I ask you, I don't know, multiply them, you will answer 6. And you know that these operations have some properties that I want to have a good list about them. So it means that, first of all, these two operations are commutative. Yes, so let me just write, because I also saw that in the book the words are mentioned. So it is called commutative. Yes? So the words are commutative. So sorry, the operations are commutative. It doesn't matter if I write 2 first and then 3, or the other way around. Neither in addition nor in multiplication. The answer would be the same. 2 plus 3 and 3 plus 2 are the same. 2 times 3, 3 times 2 are the same. Is the same. So here remember that this word is commutative. Okay. Another property that is very important is associativity. So associative. So what is the meaning of associative? Associative means that when I have two operations of the same kind, it's important. Either I have two addition operations or I have two multiplication operations, then how I prioritize those operations is irrelevant. It doesn't matter. So, and everyone knows about that, yes? If I write 2 plus 3 plus 5, it doesn't matter if I add these two first or if I add these two first. The answer is definitely the same. Of course, the way that we answer this in principle is different, because here I prioritize this addition, it becomes 5 plus 5, 10. But here I prioritize this addition, it becomes 2 plus 8, the answer is again 10. Yes? And the same is true for multiplication. It doesn't matter if I do this and then multiply it by 5, or I write 2 first and then multiply it by 3 times 5. So this means that if I have two operations of the same kind, and it doesn't matter how I prioritize them, that operation is associative. Okay? And it is extremely important to realize that this is not the case that all operations are associative. For example, division is neither commutative nor associative. Why? If I tell you 1 divided by 2, you get 0.5. If I commute them, 2 divided by 1, you get 2. And it is clear that these two numbers are not the same. So you immediately realize that this division as an operation is not commutative. Division is not associative neither, yes, either. So what you write 1 times 2 times 3, and it depends how you interpret this. If I interpret to divide these two first and then divide the answer by 3, or if I divide 2 by 3 first and then I divide this divide 1 by the answers are different. So here, if you do this, 1 divided by 2, you can write it as a fraction, and then you turn this into multiplication and you write 1 over 3, the answer is 1 over 6. But if I ask you to calculate that, I will calculate 2 over 3 first, and then I do this division, but you know how to divide. You write the first one, you turn it into the multiplication, and you swap these around. So the answer would be 3 over 2, and you see that they are not equal. So, two operations are very important for us here in mathematics, on the set of real numbers, is addition and the multiplication. The good news is that they are both commutative and associative. And associativity and commutativity is not something trivial, because I immediately gave you an example of another operation which is also familiar to you, but you see that this is neither commutative, because by changing the order the answers are the same, and this is not associative, because by changing the grouping the answers are different. But hopefully you understand that addition and multiplication are both commutative and associative. Okay, another very important thing that I want to talk about today is distributivity. Distributive. This is a little bit technical, so you need to understand. Of course, you already know that. That is a big name probably for something that you already know and are very familiar with. But I want you to deepen your knowledge a little bit here. So what is the meaning of distributive? We say that, this is the word, this is the phrase that we use. We say we say that multiplication is distributive over addition. Is distributive over addition. So you see, the way that I have to phrase it is different. Here I say addition is commutative. I only use the word addition. Here I use the word multiplication is commutative. The word associative is exactly for the same kind, operation of the same kind. Addition is associative, multiplication is associative. But here, about distribution, you need to use the two words, multiplication and addition. So we say that multiplication is distributive over addition. What does it mean? It means that if I ask you to calculate this expression, you can do it in two different ways. It is very important, the difference between algebra starts from this actually. So here, if I ask you to calculate this, you tell to yourself that, okay, this pair of brackets prioritize this operation. Because here in this expression, two operations are involved. One of them is multiplication, the other one is addition. But this pair of brackets around this tells you do this one first. The answer becomes 7. And then you multiply 2 by 7. The answer becomes 14. Probably this is the best way to do when you are facing numbers. But later we will see that if I have letters in front instead, when I'm working with algebraic expressions, this I cannot continue. Because, for example, if I give you A, B, and C, A dot B plus C, I cannot continue with this even though technically it's right, because I don't know how to add B and C, because the values are hidden yet. It's not revealed. So, we have to use another rule here. Another property is you can calculate it in a different way. You can start distributing this into this operation, into this pair of brackets, by multiplying 2 by 3, so it becomes 2 times 3, and then 2 times 4, and then add them. So what I am doing, I am using another alternative by multiplying, by distributing multiplication over this addition. And I got that. So when I ask you what is the answer would be this one is 6, this one is 8, and when I add them, the answer becomes 14. And that's exactly the same answer as before. Okay. So these three important properties, I want you to, even though you don't want to memorize the names, but at least you need to familiar with the names, that you know that you have heard these words somewhere. So these are the important properties of two operations, addition and multiplication. Okay, now in algebra, the point in algebra is to use with variables. This is another terminology that I want you to know in algebra. The notion of a variable. So a variable is actually a letter. Usually we use English letters or Latin letters, okay? Sometimes, of course, in geometry we usually use Greek letters, okay? Because of history behind geometry, mostly it is coming from Greece, yes? So here, the variable, what do I mean by a variable? You might have seen this in your previous studies. We have an expression of x plus y, but you might say this is not very strange, but in principle it should be strange, yes? Because addition is something between two numbers. So, for example, put yourself in the position of a first year student in the first year of primary school. They know how to add two numbers, and then suddenly you ask them add x and y. So it might be they get confused because they have learned so far that they can add numbers, not letters together. Yes, we don't know what to do with that. But this is what I want you to understand. When in algebra I am using letters, which I call a variable, here I have two variables, one of them is x, one of them is y, and I am adding two variables. This makes something that I call algebraic expression. It means that even though I am looking at them as letters, but I know deep inside this is a representative of a number. So x is sitting for a number, y is also sitting for a number. And then which number you cannot say unless I myself assign a number to that variable. Before doing this assignment of numbers to variables can take on every value that they like. It is not clear when I say x, I don't know the value of x. But if I say x, where x is equal to 2, then immediately x becomes 2. I don't know how much have you worked with coding and computer, things like that. It's exactly like computers. So you have different variables, then you can assign numbers to them. Okay? So here, the variable x can take on any values. So, but before assigning any value, that is representing a number. So if I ask you, what is x in this expression? You would say that x is a variable. It is sitting instead of an unknown number. It will remain unknown until I assign a value to it myself. And the same thing for y. But exactly in this problem, that is very important. If this is very important, this is a convention. If I write x plus y, even though they are different letters, but can I ask you, calculate the value of this when x is equal to 1 and y is equal to 1 or not? So I can ask you, evaluate the value of this algebraic expression for x equals to 1 and y equals to 1. Is this a meaningful question? The answer is yes. Even though I am using two different letters, one x and one y, but still I am allowed to assign them the same number. Be careful about that. This is a convention which is usually not mentioned directly. If I have an algebraic expression with different variables involved, it doesn't necessarily mean that I have to be very careful by assigning different numbers to them because they are using different letters. No. Okay? So if I have two different letters, if I want to, I can choose different values, but if I want to, I can choose the same values for those different letters. So that is one convention that you need to have in mind. But the other way around, if I ask you to calculate this for x equals to 1, then you have to respect. In that algebraic expression, if x appears in several places, all those x's are referring to the same number at the same time. Yes? So if I ask you to calculate this expression for x equals to 1, you are not allowed to put 1 here, and they say that because this is variable and it can attain a lot of number, let me choose 1 for this x, 2 for that x. No, it is not possible. Yes? So if you want to have the possibility of different values, you have to use different letters. If you use the same letter in one algebraic expression, when you assign a value to that variable, you have to respect to assign the same value for that x all over that expression. Yes? Okay? So don't get confused that because I have different letters, the values should also be different. No, it might be different or might be the same. Okay, so everything that you can, everything, for example, this is a meaningful number. This is a meaningful number, for example, 2 plus 3, and then I have 5 minus 2. This is a number, yes? If you want to, you can replace any number by any variable that you like. Then what you get is called an algebraic expression. Whatever you can imagine as numbers. For example, let me pick this number x and put it x. Then I will get this. So this, what you have created is called an algebraic expression. So algebraic expression is an expression that uses mathematical operations, here subtraction, addition, and division, with numbers and letters involved. But if someone asks you what is the meaning of that letter, you would say that that letter is a representative of some number, which number we don't know, until someone tells us what number we have to assign. Yes? That's it. So I want you to understand this. Okay, and then the problem is this. Here, if I ask you to write commutativity, by the way, what is the good point about algebra? Why we should bother to work with letters instead of numbers? Yes?
Maybe because it makes it less complicated?
This can be, yes, but can you say, for example, how? But no, usually it makes it a little bit more complicated, but the price that we pay, yes?
It makes it easier to define the unknown.
Yes. Yes, you?
Easier to find patterns.
Yes, good, yes? That was my intention. So for example, if I ask you, if I give you this, this is a rectangle, I tell you that the width, for example, is 2, and the length is 5, for example, then I can ask you about the circumference or perimeter. Omkrets in Swedish, you say, yes? If you want to calculate this, of course you can. You would say this is 2, this is 2, this is 5, and then I start adding them, 2 plus 5 plus 2 plus 5, and then it becomes 7, 7 is 14, I don't know, length unit, for example. But if I change these numbers, then you have to do the calculation again. But if you want to write a code, okay, so that the computer knows how to calculate the circumference of a rectangle, of course you can just type everything one by one. But the easier way is to give a formula to the computer and then write the program in a way that the computer asks you about the length and the width. As soon as you type it there, the computer knows how to calculate the circumference. So how should you do that? You need to define a formula so that you can implement in your code. Okay? So Being able to define a formula means working with algebra. What is the meaning? You might say that, okay, let us take this height can be any number, so let me call it A. When I call it 2, I am not allowed to change it. And when I say that the length, the height is 2, the width is 5, there is exactly one rectangle which is fixed. But how many rectangles you can imagine? You can imagine infinitely many rectangles. But when I write that the height is A and the width is B centimeters, for example, then in principle I am considering not one rectangle. I am considering all possible rectangles. How? Because I am telling you that A is a variable, I can change it. By the way, any variable has a domain in which it can work. For example, here, can I say that A is -2? It is nonsense in this context, yes, because the length of a segment cannot be negative. So in this case, you know that A should be positive, and B should also be positive. So what does it mean? It means that I am not allowed to assign negative numbers. For example, and now let me write the parameter. For example, let me write the parameter is equal to, if this is A, this is also A. If this is B, this is also B. And then this becomes A plus B plus A plus B. But can I simplify that? It becomes 2A plus 2B. And then what can I do? I can write P, and I can, for example, write it as 2 times A plus B. Why this is correct? Because of distributive law. 2 times A, 2 times B is the same as what I have written here. So if you can find a formula for the area, for the circumference, then you can start immediately writing your code. Yes, you can write, by the way, this is also good. You know how to do this coding. Do you know any languages? Probably you will learn in technique programs. So Python probably is good. I myself use Matematik always because I don't want to program something else. So that's a different language on its own. It's a higher level language. It's not very close to the machine language, but it has a lot of options and functions available. So here you should be able to write a code that this code asks you for 2 numbers, and immediately when you punch those numbers in, it gives you the parameter of the rectangle. For this, you have to have algebra, because you need to give this formula to your code so that when I put A and B, it generates the parameter. So I think the one that actually Tim answered is very close to what I wanted to mention. So this is the reason. When for example, if you learned working with algebra, so then you can work algebraically and simplify everything once, and then you can use that for later applications. So that's the main point of learning about algebra. Okay. So something that I want to repeat here again. So can I add, for example, this is an algebraic expression. What does it mean? What is the operation between 2 and x? It's multiplication. What is x? We still don't know. I can only answer what is x when I know what the value of x somehow. Someone gives it to me or myself find it. Otherwise, I prefer to work with 2x. And I want to add it to 3x. So what's the answer?
5x.
It's 5x. But I just want you to know how. Why is this? Yes? Yes? So why is this? Can you tell me which property is involved here? This is deeper understanding. Yes, Simon?
2x and 3x can be rewritten, so it's only 2x is equal to x plus x, and 3x is equal to x plus x plus x.
That is correct, but simpler than that. One of the properties that I just used on the board, there were 3 important rules: commutativity, associativity, and I told you that mainly in algebra, distribution of multiplication over addition is important. You can start from that scratch, everything, that's correct. But I also want you to tell me which one of these rules is applied here when I write 2x plus 3x is 5x. Yes, Rasmus?
It's the fact that multiplication is distributed over
Yes.
addition.
Exactly.
It's
Why is that? Because what you are doing here, you have written x here, and then you have written 2 plus 3. Can I write this as this? The reason that I can write this in this form is because of distributive law, because this can distribute here itself and I get this back. But when I come to this stage, 2 plus 3 is 5, so it becomes 5. Of course, I really don't want you to bother to write this, but I want you to understand. The reason that I am asking, because when I give you this, many students answer, but when I give you this, some people get confused. So what can I write in front of this? I want you to understand these are the same things. This is my experience. People can answer this quickly, but they get some trouble when I ask you this question. So what should I do here? Yes?
Can we start as usual with like multiplying, finding the common denominator?
Yes, that is possible. Yes, that's possible. Yes. But one more thing that I want to mention, this is what I want you to understand, especially in algebra. A fraction of a over b, I want you to understand, do you really understand there is no difference between this and that?
Yes.
This is very important. Okay, so there is no difference between this and that way of writing. So be careful, these are the same. Okay? So here I would say that another way that I can imagine this is x is 1/3 times x. Agree? X over 3 is another name for this combination, and x over 5 is another name for this combination. Yes? Okay, if I ask you to calculate this, what is the answer? The answer is exactly the same method. But these numbers were so simple for you that you really don't bother go through this step. You did it quickly in your head and answer 5x. But if you ask your brain, how did you do that? Your brain actually did this. Do you agree with me? Because your brain knew about x will be repeated and then asked itself that what is 2 plus 3? This one is done in your head. It was easy, so you were able to do it in your head. But this one is a little bit tricky for our brain to do it in our head. But still, if your understanding is complete, what do you write? Can you tell me? What should I write? I should write 1/3 plus 1/5 x. Yes, the same story. If I ask you what property I used here, you say distributive of distribution. If I ask you what property I used to come from here to here, you would say again distribution. Yes? So you need to teach yourself why you were able to answer this quickly, but you might have trouble if you had about answering this. And now you ask them, now what you said is correct. How should I add these two numbers? If I can do it in my head, I do it. Otherwise, I go to a scratch paper or use my calculator or whatever. So this becomes 15. This is 5 times, this is 3 times, so it becomes 8 over 15. So the answer would be 8 over 15x. Yes? Okay, but I want you to understand, there is no difference from conceptual point of view between this simple calculation and this a little bit harder calculation. So if someone asks you what is the main rule behind this, you should say distributive law. Is that understandable? Okay, so let me ask you to do some more calculations. For example, can I write something for this? I have a squared b divided by 3 minus 1 over 5 a squared b plus 3a squared b. I want to wait a little bit for you. Make sure that you don't do any mistakes. Can you write this in the most compact form? Simplify this algebraic expression as much as possible. I just wait 2 minutes. Any answers? Anyone else? Yes.
Just the actual answer.
Yes.
1/3 minus 1/5 plus 3.
No, the final answer.
Oh, the final answer. Okay.
Yes, yes, the
then
final.
Then I'll have to.
Yes, the final answer is important. Of course, that is very important to understand what takes you to the final answer. But the final answer, yes, Tip. May you repeat? Yes, I think it's good. A squared b. Yes. Yes, that's correct. Yeah, but of course, in algebra I do not prefer to write mixed fractions. So I will keep it as one fraction instead of writing mixed fraction. That's my preference. So, what is important is to understand what is going on. First of all, you see that if you see why this is working, again, that is distributive law. Why? Because if I ask you what is another name for this, what is another name? Is a third multiplied by a squared b. A squared b. Again, a squared b, a squared b. I can pull a squared b out if someone asks you why, because I can use the distributive law. And then the factor 1/3 and the factor minus 1/5 and the factor of 3 should be correspondingly added or subtracted. Yes? And then, if this is easy, you do it in your head. If that's not easy, if the calculator is allowed, you can use your calculator, or you can go to a scratch work paper and then just calculate this. And I want you to do it quickly, yes? What is the denominator for 3 is 1. What is the common denominator between these three? The least common denominator is 15. Just draw a little bit longer fractional line and ask yourself, 15 divided by 3 is 5 times. Multiply 5 in the numerator, it becomes 5. And then you have a minus sign and ask yourself the same question. 15 divided by 5 is 3 times. Multiplied by the numerator, it becomes 3. 15 divided by 1 is 15 times. Multiplied there, it becomes 45. And then if you calculate this, 5 plus 45 is 50, minus 3 is 47. So 47 over 15. Whenever this is done in scratch paper, you bring it back, and then you put 47 over 15, a squared b. Okay, this is very important. If you solve this and you go to faucet and see the faucet is written this, do you agree that they are the same thing or not? These things I want you to immediately understand. Do you agree that there are no difference between these two whatsoever? Yes? So it depends. I myself prefer to write it in that way because usually algebraic expressions, yes?
You accidentally added another square,
Oh yes, thank you. Thank you.
but otherwise the same.
Yes, thank you very much. They are not the same in that way. Yes, but here, if you write it in that way, I prefer to write it in this way. Why? By the way, what is the name of this number which is multiplied to an algebraic expression? Of course, the whole expression, the whole thing is called an algebraic expression. This is the literal part, and this one is called. That's also the same word in Swedish, I think, but probably different. Yes.
Constant?
No, it's not called constant. Of course, it's a constant, but this is called coefficient. Okay? If you haven't heard, because I saw that even in the book, this is the same word with different spellings. Coefficient. Coefficient is a multiplicative constant sitting next to the algebraic part. That's called coefficient. It's good to know. So if I ask you what is the 5, you say 5 is the coefficient of this. 3 is the coefficient of this term, and 2 is the coefficient of that term. So I can say that here I have written x, I have added the coefficients to get the answer. Okay, but the important thing is that when I want to add algebraic expressions, I need to respect the similarity of the literal parts. This is very important. And I want you to understand why. For example, if I ask you calculate x plus x, Of course, this is the bad word to calculate. There is nothing to calculate. I should ask you to simplify this expression, and then you write 2x for me. If I ask you the same question here, x plus x squared, and I ask you to simplify this, I want you to understand that I cannot move forward. Yes? Why is that? Because assume that x is 5. Okay? If I ask you to calculate this for 5, you replace x with 5 everywhere. But can I start with this addition operation? No, the priority is with this power. But the point is that when I have numbers, I can write something for it. The answer is 25. When I get 25, I add it to 5. So this addition comes later. But here, when I am facing with letters, I cannot actually continue with this part. If you ask me what can I write instead of x squared, I can say nothing. X squared is just x squared. And then, because the priority is with this power, and this cannot be accomplished, I cannot go to the next step. So it means that if I ask you to simplify this expression, you do nothing and just leave it. Is that clear? But if I ask you, can you write something for this one, what would be the answer then? Yes? It is 2x squared again. Why? What is the difference here? Because here, even though you have to do this power first, and you cannot do, but you know something. You know whatever this is, that is the same expression. So here I can add them and write 2x squared. But I cannot go further. So if I want to give you a rule of thumb, if you want to add or subtract algebraic expressions, they have to have the same letter part identically. And otherwise you cannot continue. For example, I can add 5a squared b cubed and 6a squared b cubed. This is possible. Because I would say that this term is similar to this term. If I have similar terms, I want to add them, I write the identical letter part and I add or subtract the coefficients correspondingly. Here I have addition, I add it in my head, it's simple, so I put here, it becomes 11. But if I just change one of them, I cannot do anything. Of course I can do a lot of things, but not addition. If I give you this, you just stop there. You cannot simplify it more. So to simplify it more, the letter part should be identical. Yes? Okay, so let us solve some problems here together to see how it goes. Okay, so let me write this, for example. I have 5x cubed minus 3x squared plus x, and then I have minus 1 over 2x plus 5x squared negative 4x cubed. So for example, I want to simplify this, and then let me add one number 10 here and minus 11 here. Something like this. I want to simplify this expression. So if I want to do it, I see an algebraic expression in front of me. They have different parts. Some of them have cubic power of x, some of them have second power, and some of them has the first power, and some of them are not related to anything. The word constant that Rasmus said is these numbers. These are not coefficients. Minus 10 and 10 are constant terms. Yes?
Get that now.
Yeah. Okay, so here, what should I do? The first thing that you need to do is to recognize which are similar together. So minus 11, there is no letter involved in minus 11. There is no letter involved in positive 10. So they are similar. But 5x cubed, let me just underline it with 2 small lines. And this one are similar. Yes? because the letter part is x cubed exactly. So, but this one, for example, I don't know how to show it, this one and this one are also similar. And then finally, hopefully you agree with me that this one and that one are also similar. I agree, the algebraic calculations are boring, but you have to improve your skill. It's really, really important. There is nothing deep and conceptual in it. Might be your brain gets bored, but you have to do it. Okay, so what should I do? I would say that this one is similar with that one, so it means that I can add or subtract them together. So what would be the answer? Minus 11 plus 10. What's the answer? Minus 1. So you have to write equality. This is have to, and then you write minus 1. Okay, and then I go to the next 5x cubed. This one is similar to that one. Can you tell me what would be the answer?
1x cubed.
Yes, 1x cubed, and we don't write 1x cubed. Because 1x cubed is of course not wrong, it's completely acceptable, but no one write 1 because this means 1 multiplied by x cubed, but you know that any number multiplied by 1 is just x cubed. Is the number itself. So it becomes positive x cubed. The next term is this one and that one. So what's the answer? Everyone? What's the answer?
8x.
No, be careful.
Minus.
2x.
Positive 2x squared. And then finally these two terms. What's the answer? Can you do it in your head or you need a scratch paper? Let me ask you one question. What is the coefficient of x here? Negative 1/2. That's very good that you also mentioned the negative part. What is the coefficient of x here? It's 1. When it is not written anything, it is 1. If I ask you what is the coefficient of x, you can say 1. Because 1 multiplied by x is equal to x. So, the coefficient of this one is 1. The coefficient of that one is minus 1/2. Can I do this in my head? Of course. 1 minus 1/2 is 1/2. So what should I write? I would write 1/2 x. Yes? So that would be your answer. If your friend got the answer in this form, do you think this is the same answer or not? So, do you think this expression is exactly that expression?
Yes.
Yes or no?
Yes. Yes.
That is a yes. Okay? As far as you replace them with the signs, that is okay. So let me just mention, this is extremely important. I have seen many students make mistakes. Is there any difference between a plus b and b plus a? No, they are the same. But a minus b and b minus a, are they the same?
No.
No. Be careful, they are not the same. But a minus b and minus b plus a, what do you think about these two?
Yeah, that's
They are the same. So if you start moving them around and keep the sign behind them as it is, then you get an equality sign. But if you just naively just interchange the letters, keep the negative sign, this is not equality. Because if I ask you what is the sign of A, you would say nothing is written, so it's positive. But what is the sign of A is negative, so they cannot be equal. But the sign of A is positive, the sign of A is still positive, the sign of B is negative, the sign of B is still negative. So pay attention to these very, very simple simple points, otherwise you will actually get wrong answers all the time. Okay, now let me give you something with pair of brackets. Let me ask you, what do you think here? If I write something like this, for example, 2x plus 1, and then I have minus, and then I will have 1 minus 3x. And I want you to simplify this expression. So I really want you to learn this once for all. If I remember when I was at your age, it was not hard because I really paid attention to the teacher. But every now and then I see that the students will forget about what to do this properly. So what should I do? I should remove these pair of brackets to simplify them. If I want to remove this pair of brackets, I have to check what is behind this pair of brackets. For the time being, I haven't put any numbers there. I will talk about what happens if I have numbers. Here, I just remove the pair of brackets without any difficulties because nothing is behind this pair of brackets. But here, many students usually make this mistake. They remove this pair of brackets and they write -1 minus 3x. This way of removing the pair of brackets is wrong. If you might feel not very confident, please write this and cross this over, that you realize that this is really wrong. The correct one is you have to put this positive. And why is the reason? Because if I ask you what is a plus b, if I ask you what is the coefficient here, if I insist, you would say that, okay, this is just 1. Because 1 multiplied by a plus b is just a plus b. But I learned that I can distribute this multiplication here. So this becomes 1 times a plus 1 times b, but no one writes 1 times a, there is a simpler name. No one writes 1 times b, there is a simpler name. So this is the reason. If I have this pair, just simply take it over. You don't need it. But if I have a negative sign behind, another way of writing this is -1 multiplied by a plus b. These two are the same thing. Then you use distributive law to distribute this here. It becomes -1 times a plus -1 times b. Then if I ask you what is a better way to write this, you would say minus a and then plus. What is a better way to write this? It is minus b, but there is also another better way to write this, and that is minus b. And now if you compare this one with that one, you see that minus sign is not just for the first one, but also for the second one. This you need to convince yourself and always use it. Okay? So if I want to simplify this expression, what do? I use this rule. Without any problems, I just remove this pair of brackets, nothing is behind it. So this becomes 2x plus 1. But when I want to remove this pair of brackets, I remember that this minus sign should go here and here. So this becomes -1, minus times minus becomes positive 3x. And then the rule is the same rule. This one and that one are similar. This one and that one are also similar. Okay, 2x and 3x becomes 5x. 1 minus 1 is 0, but no one writes 0 if that is an additive 0. And the answer would be 5x. Yes? So let me give you a little bit a more interesting problem. So here what happens if I have some coefficient behind that? So we want to simplify this expression. So how should I do that? Yes? By the way, if you want to understand this, what is the structure here? Don't get confused. This is, if I ask you what is this in algebra, you would say this is an algebraic expression. But remember that algebraic expressions at the end of the day are numbers. Okay? But written in a little bit fancy way. But they are numbers. So, if I want to compare this structure of, the structure of this is something similar to 3 times, I don't know, 7 minus 4 times 10. It is, I don't believe any one of you cannot solve this. If I ask you to calculate this, how you calculate this? Definitely you will do this multiplication first, you do this multiplication and then subtract. So the same thing is here. This is a product This is also a product, and then I have subtraction. But I know that the product, this multiplication has priority. So it means that I concentrate on writing something for it by distributive law. Yes? So 3 times 5x squared is 15x squared. The next one is minus 6x. The next one is positive 3. Okay, you know that here I have to do the multiplication first. So I keep the sign and then I multiply 4 inside. So it becomes 4 minus 4x squared plus 12x. The next step, I have to remove this pair of brackets, but I need to take a lesson from what is going on the board. So what is the answer? Minus sign is not for the first one only, but also for the second one and also the third one. So then it becomes minus 4. Minus 4 times minus 4x squared, positive 4x squared, minus times 12 is minus 12x. Is the problem finished? By the way, I have to put equality all the way around. No, it's not finished yet because you have to simplify as much as possible. And then what I have to do, I have to find actually the similar terms. This one and this one are similar. These two are also similar. And this number without any letters involved and this number are also similar. Okay, so I would say 15x, I had it, 4x squared is added to it, so it's 19x squared. Minus 6x minus 12x is how much? Yes, minus 18. How many of you doubt that you have to do minus 18? Some people I have seen, they start multiplying sometimes. Don't get confused. They say that minus 6 and minus 12 are multiplied. No, I am adding them, yes? So I have minus 6x minus 12x. It's minus 18x. And between 3 and minus 4, I can simply write minus 1. So I know I agree, this is a little bit boring, especially for me now. But it is extremely important to be 100% precise, to be able to answer, to find the final answer without even one single mistake. Yes, you need to be a little bit patient to calculate a lot of these calculations. Yes? Okay, so I think these are not that hard. These are simple. Okay, I want to teach you one more thing and then we are done. Of course, this one more thing is important. I will spend a little bit of time on this one. Let me see if the book has talked about. Yes. So addition and subtraction of these algebraic expressions are not that hard. But let me also teach you about multiplication and then we can solve nicer problems because we can combine them. Yes? So multiplication is again nothing except distribution law. But I want you to understand this method and then we can start using it. So let me start from distributive law again. What is distributive law? Distributive law tells you that if you have A here multiplied by B plus C, it becomes A times B plus A times C, but of course usually we do not write this dot. By the way, if you want to be very pedantic and say everything, this is called distribution from the left. Because A is sitting on the left side, I am distributing it from the left. But do you think we can also have distribution from the right or no? Because that's clear, yes? Can I write this one? Yes? That's also true, yes? Okay, but now I want to ask you another question. A plus B, what happens if I want to multiply A plus B by C plus D? Okay, so here it seems it is not exactly the same rule, because in the fundamental rule, 3 numbers are involved. One of them I called A, the other one B, the other one C, but in this expression there are 4 numbers involved. This is a very nice trick I want you to learn. If I want to calculate this, I can pretend that these are 3 numbers, yes?
Don't you just multiply A by CD and B by CD and
Yes.
add? Yeah.
Yes, but I want to see why this is working. I can give you the rule, but I just want you to not to memorize, to understand. Okay, this is important for me that you understand. I call this in my head A. Okay? And now, if you do not look here, then how many numbers are involved? If you want to name them, it is capital A and little c and little d. Again, I have 3 numbers. So I can use distributive law, because distributive law is for 3 numbers. Yes? So what can I do? I can write the capital A multiplied by C plus capital A multiplied by D. But A was not in the beginning, the capital A was not in the problem from the beginning. I bring it in myself, but A is nothing except A plus B. So I replace capital A everywhere with A plus B. Yes? So what I am doing, even though there are 4 numbers, but by this trick, I can see it in the terms of 3 numbers. Capital A, little c, little d. And I use distribution law. But now, how many numbers are involved here? 3 numbers. Can I use distribution law? Yes. How many numbers are involved here? 3. Can I use it? Yes. And then you multiply it, it becomes AC plus BC plus AD plus BD. And that's exactly what you said. But if someone asks you why this is correct, you need to understand how many times I use distribution law to reach to this? 3 times. 1 here, 1 here, 1 here. So, in order to be able to write something simple as that, I have to use distribution law 3 times. So it is very, very important to understand these deep connections. But from now on, don't do that. If I give you 2 pair of brackets and I ask you to multiply them, just multiply them in this way. If I give you A plus B, I myself do it like this. If someone asks me why this is correct, I can explain, but I myself never do it like this. I will take 1 term here and then patiently multiply it by everything in the second one. And when it is finished, I go and choose another term and multiply it by everything again here. I will do this process until everything is finished. So what happens? I will take A, multiply it here, it becomes AC. I multiply A by D, it becomes AD. I multiply B by C, it becomes BC. I multiply B by D, it becomes BD. So if you give me this, I myself do it in that way. If you check this one with that one, you see they are exactly the same. AC, AC, AD, AD, BC, BC, and BD, BD. So now let us solve some more interesting problems of multiplication. Okay? Of course, I don't want to increase the level immediately. I want to make sure that you really understand what's going on, and then we can solve a little bit more nicer problems. Okay, so let us do this together. X plus 1, x plus 2. I want to multiply these two. Yes? And by the way, I can ask different questions. I can ask, do the following multiplication and simplify. I can ask, expand and simplify. I can just simply say simplify. So all of them means the same thing. What should I do? How many terms are involved in the first pair of brackets? 2 terms. One of them is called x, the other one is called 1. How many pairs are there? How many terms are there? 2. You need to take one of them, multiply it by every one of them, and then switch to the other term and multiply the same thing. And then simplify, do not forget. So let us just do it together. So x times x is?
Sure.
No, be careful.
X to the power.
Yes, Are you sure that x times x is x squared? And then take x by 2, it becomes 2x. And then take 1 by x, it becomes 1x, so that I write just x. And 1 times 2 is 2. If you stop here, it is not complete because you can simplify more. There is no similar term for x2, there is no similar term for 2, but this one and that one are similar. So the answer becomes 3x plus 2. Yes? Yes or no? Okay, I will write some of them here. If you are tired, you can rest a little bit. Yes. Do you want to rest a little bit? Yes or no? Okay, so 5 minutes. Okay, whenever you feel that you have enough energy to come back, I want you to do this, and then I will solve them for you.
Okay.
Yes, so Ali wants to solve the first problem. Any pen that you want to. I think if you change the color, it will be better because that's the solution. Blue is good. Yeah, please listen to him and respect him. Yes. Yeah, doesn't matter. Number 1.
Can you please explain? Can he explain?
Yes.
First,
You need to listen and respect.
I
Yes.
took 2x times 5, which
Yes.
is 10x.
10x.
Then 2x times 4x, which is x
Yes.
Then we move on to minus 3.
Yes.
Minus 3 times 5 is minus 15.
Yes.
And minus 3 times plus 4x is minus 12x.
Okay, just wait here. There is a very small flaw in what he has written. Very small one. Can anyone detect? Yes, Sergey?
The addition sign?
Yes. Which one is missing?
This time.
Yes, you yourself. Yeah, okay. So you see, sometimes I have seen if you forget that, then you suddenly think that that's a multiplication. Be careful about that. Okay, can I simplify this more?
Yes.
Yes, please.
10x and 12x can be put together.
Yes.
And I can write it as
Minus 2x.
And the other ones I can't do anything, so I just write them.
So let me see. Minus 15, minus 2x, and minus. Yes, thank you very much. Yes, just. So it's good. You want to go?
It's not. It's minus 2x as well, right?
Minus 2x.
Well, it's 10x. It's 10x minus 12x, right?
It's minus 2x.
Oh, okay. Oh, sorry.
And then 8x squared and minus 15.
I didn't see it.
If you change the order, that's also okay. But this answer is completely correct. Thank you very much. Another person? Yes, please. You will be on YouTube, no problems? No problem. Yes, whatever you want. Now you are the teacher.
Okay.
Yeah, please listen. Please keep silent and listen. Yes. Number 2.
Number 2. Should I write it all out for like as it was?
Try to explain and solve it. It's better.
Okay. Well, I started with taking the first 2x multiplied by 4x to the power of 2.
Yes.
And that becomes then 8x to the power of 3.
Yes.
And then it was 2x times 2x times 2x, which is 4x to the power of 2.
Yes.
And then was 2x times 1, which is 2x.
Yes.
Okay, so the second one, it's -1, so it's -1 times times 4 to the power of, like 4x to the power of 2.
Yes.
That is minus 4x to the power of 8. It's like it's just -1, so it's just the same thing except minus.
Yes, yes.
2x minus 1, and then these cancel each other out.
Oh, many of them cancelled actually.
Yeah, so it's 8x to the power of 3 minus 1.
Yes, very, very good. Thank you. Okay. Next one. But by the way, this was a nice problem. You see, many terms cancelled out actually. So now you see that this is algebraically very, very nice. Instead of working with this expression, which is a little bit lengthy, we can replace and work with this expression, which is more compact and short. So that is the power of algebra. So you shouldn't underestimate algebra. Okay, for the next one, any volunteers?
Can you do it again?
Let us give the chance to someone else. No one else? Now I know that most of you can solve the problem, but you need to dare come here. It's nothing. If you don't like them much, I can cut the video, but I don't make trouble for me. Okay, otherwise I have to do a lot of things.
Well, I can do it.
Yes, Rasmus, thank you. Yes. Okay, so let me clean these. Now, by the way, when you come on here, you can take the initiative. I don't know if you want to change the color, if you want to look at the students and talk. That's up to you.
Yes.
Yes.
So,
By the way, you will be on YouTube. No problems.
yeah, no, I don't.
No, please listen. When he's talking, you have to respect and be silent. Yes.
Just going to write it over here, or so I don't miss anything.
Yes, you want to write the question in front of your eyes. That's very good.
I think that's it. Isn't zero. No one.
Yes. Now he becomes independent of what I have written. Yes.
Yes, that's correct.
Let me double check.
Okay,
Yes,
so
that's correct.
then we need to do this thing where we multiply everything in this one with all of them. So and
It's very good.
and then we do the same thing with this one, but it will get very boring. I can use a different color.
Yes, yes, thank you very much. That's very good.
No, wait.
Yeah, you can do it from the. This is also some kind of practice. That's really important, by the way. They don't dry easily. You don't need to replace the caps.
Okay.
Yes, good. That would be the second step.
Yes, okay, so now we multiply them. Well, this first one, 2 multiplied by AB squared and times 4A cubed. Then we can start by multiplying the two coefficients, 4 and 2. So that becomes 8. Then we can see this A, I'm just going to write it over here. AB squared, that's the same thing as, or AB times A squared. Then because multiplication is commutative, I think. That's commutative, right? Yeah. then that's the same thing as a 8 to the power 4 times b squared. So then we can write that over here. And now we need to do that a lot more times for all the different factors. Oh no,
Yeah, please keep
things.
silence.
Hello. So then we can do the same thing with these two. 2 times 3, that's 6. Oh yeah, maybe we should start by checking the signs. That is positive. Both are positive, so then it's still positive. So that's 6 times a squared and a, that becomes a to the power 3. And b squared times b is the same thing as b squared. No, b cubed.
Yes.
And we do the same thing with 2ab squared and b cubed, and fortunately here we just have b cubed, so we don't need to do many calculations. It's just 2a and then b squared times b cubed, which is we add 2 and 3 together, so then we have b to the power of 5. I don't recognize this.
No, that's correct. I'm checking that. No worries.
Yeah, maybe. Yeah, I guess maybe my first answer was incorrect. Okay. Maybe we can write this on a new line. I know. Will it be more easy?
No, just continue, I think.
Yeah, I'm just thinking if it will be like easier to see what we're doing if I write the new.
So take the
Let's do it,
initiative.
yeah.
That's now you are the teacher.
Let's do it on the same line.
Oh, sorry.
So now we need to multiply my negative a squared times b and positive 4a cubed, and then because we have a negative sign, then and a positive sign, then we have a negative. That becomes a negative sign. Here we don't have a coefficient, or the coefficient is 1, so then the coefficient just becomes 4. Then we have a squared and a cubed, which becomes a to the power of 5. And we don't have a b in the second factor, so just keep the b from there. Now we should make some space. Then we have negative a. Yeah, then we need to multiply negative a squared and b with 3a squared and b. Oh. Which becomes, the sign is negative again, because we have a negative sign and a positive sign. Then we have a 1 here, or coefficient of 1, and 3 here, so that just becomes 3. Then the a squared times a squared, that's just a to the power 4, and b times b is just b squared. And then lastly, we multiply negative a squared times b with b to b cubed, which is negative again. And a squared and b times b cubed is b4. So now we have a lot of different, can't remember what it was called when it was a whole package, but coefficient and a variable. Is there a name for that?
Yes, you have a lot of terms involved.
Terms,
Yeah.
that's what it's called. Then we need to check if we have like not a variable but a package that match or are the same. And the only one I see is a to the power 4 times b squared, which are here and
Yes, and they are really the only ones.
Yep. So then that becomes quite easy. We just add these two together, or subtract it in this case. So 8 minus 3 is then it's 5, I think.
Yes.
Yes. So then you have 5 a to the power 4 times b squared. And then we just keep everything else the
Yes.
same. So and I think this is the final answer. Or?
Very small, very small mistake.
Yeah.
In the term last to the one to the last. You have
B to the
written
power of-
4 minus 4 a to the 5 b to the 5 if I see it correctly.
B.
Yes, I see.
But this should be only.
Yeah. Okay. That should be the final
Yes,
answer.
thank you very much. It was a very nice explanation. And thank you for listening. I recommend you to solve this one at home. Thank you very much. Have a nice day. Bye bye.